Okay, here we are. It is Friday, September 30th. And hopefully you're sitting comfortably in your dorm room somewhere watching this video. And we're going to talk about tangent planes to surfaces. And now your book, I took all the notes from the book and I keep looking at it and it's kind of driving me crazy because it feels like we're reinventing the wheel. So let's back up a little bit here and recall. If we want to find the equation of a plane, if we remember what we need is we need a point on the plane and we need a vector that's normal to that plane, right? And if the normal vector has AI plus BJ plus CK, this is all from section 12.5. We did all the stuff before. If the normal vector has that and this thing's perpendicular to the plane, it doesn't have to be at the point as long as it's perpendicular to the plane, then the equation of the plane is what? It's A times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. And you solve this for a, b, and c, or sorry, x, y, and z, and you get the equation of the plane. Okay, keep this picture in your head. It'll make what's about to happen easier. All right, so now we move back to 3 space here. What we have is, I'm going to do it this way. We have a z function equal to xy, right? And we know that from our last, from 14.5, we know that if you take any point and any parametrized smooth curve on this surface, we know that del f dot dr dt equals 0, and this is for some r which is gi plus hj plus kk, right? And r is a function of t. Okay, so at every point along R, del f is orthogonal to the vector v, which is the velocity vector. Okay, so if we pick a point P naught, and consider every curve on the surface passing through P naught, then all the velocity vectors, so all the v's, I'll call it v sub I, lie in the same plane. And they're all orthogonal to del f. So check this out. Here's the picture I want you to keep in your head. Okay, I'll make this a full screen here. Here's my surface. Right? This is the surface. Z equals f of xy. Somewhere on here is this lonely point P naught, which has the coordinates x naught, y naught, f of x naught, y naught. Okay. So if I take any, where's the blue? If I take a curve through here, think of this as R1, I'm going to find the gradient vector, sorry, the velocity vector, say, going like this. And if I pick a different v, sorry, a different r, going through here, it also has velocity vector v. And all of these little velocity vectors, and whatever the r's are, they're all in the same plane, and they're orthogonal to del f. Right? And so now what we have is we have a plane, this green plane of vectors, tangent vectors at this point, P naught. And this del f is orthogonal to all of them, so it acts as the normal. So del f is normal to the tangent plane. Right? So I'll draw this even neater. So one more screen here. Here's my point P naught. Here's a velocity vector. Here's a velocity vector. Here's another one, right? They're all going to lie in this green plane. And perpendicular to all these vectors is the gradient. Right, we did a computation in class to show that del f dotted with v, which is dr dt, equals 0. So the dot product tells us that they're orthogonal. So del f is the normal to the plane. I don't know why your book made this so complicated. You just go back to this equation here that we had in 12.5, and we find a, b, and c from del f. Right, so our current picture looks like this. Here's the plane. Here's the point. And my normal vector is just del f. And so what you have now is, what is this? This is f sub xi plus f sub yj plus f sub z k. Oh, why did that do that? Uh-oh. How do I switch it? Uh-oh. I didn't mean it to turn sideways like that. Oh my goodness, what happened to me here? Anyways, so here's A, here's B, and here's C. So tangent plane has the point f sub x times x minus x naught plus f sub y times y minus y naught, and we have to do something with the z. So here's what we do. Z equals f of xy. So we make the level curve f of xy minus z equals 0. And so f of z is negative 1. So minus z naught equals 0. That's it.